is the electrics compartment of Smarty Van 2.0, Sarah's van. And the team at Nomadic like to build these modules out on the Workbench so they're easier to wire. I think it's a great idea. And you can see they've started populating this box with Victron electrical components. If this was like our van, we would have started just placing components and figuring out what we needed as we went and then run wires. It would be a little bit of a rat's nest, but not this time. My very first design principle is design before you build, and we're gonna do just that. I wanna place every component digitally before I start bolting it onto the walls, and I want to plan where the wire routing is going to go so that we can conceal the wiring and make it super serviceable. So I'm going to show you my workflow to go from physical space to a digital model so that you can make sure you've got everything placed where you want it before you install it. And you can easily use this technology to visualize your entire build. What if you could walk through your vehicle and imagine your layout by looking through an augmented reality screen? I'm going to show you just how to do that. But first, you might have noticed this looks a little different than the average Smarty Van video. That is, unless of course you're a member. This is the style of the members only videos where we just kind of hang out and do work together. So if you're not a member and you like this style of content, click the join button down below and learn all about Smarty Van memberships. All right, let's get to work. All right, let's do some CAD work. I like to use Fusion 360, but you could really use any 3D software you like. I think Fusion still has a free version if you use it for personal use. I'll try to leave a link down below for that. So I'm not going to show you every single step to build this box, but I do want to get us started here if you've never used Fusion or a parametric CAD software. So this is a blank document, and we build in Fusion with sketches. So I'm going to create a sketch on this origin plane, this bottom plane here. And using the dimensions that we took out on the box, I'm going to just create a rectangle from the origin with the depth of 16 inches and the width of 19 1/8 inches. And that's our footprint of that box. If I click the home button there, we can see that whole footprint. And that's really all we need to get started. I'm going to finish that sketch, select this plane, and then I'm going to extrude it up the height of our box, which was 31 inches. There we go. And now we have the basic shape of that box. It's missing a few details, but this is how you get started. And in parametric design, you can go backwards on this timeline and modify things you've done in the past, and they'll affect things that happen in the future. That's the beauty of parametric design. All right, so we've got our cube here, and the next thing we need to do is shell it out. I took measurements from the outside of this material, and I know it's 3/4 inch plywood that was used to build it. So I'm gonna use a shell command, and I'm gonna set this to 0.75 inches. And now we can see, as long as we choose the inside direction, that we have created a shell. And that means these are 3/4 inches wide here, and our inside dimensions should match the shell outside. I'm going to turn the origin off so we can see that cleanly. Now you say we're missing some of the features, like this back corner that was cut off and the cable pass-through. Let's take a look at how you might add something like that in a parametric design. As I mentioned, you can go back to old items in the timeline. You can scrub here if you want to see them, or you can just double click them to edit them. So I'm going to edit this sketch a little bit. I'm going to move this a little, tidy up. Okay, so we know we need to lop off this corner. So I'm just going to use a simple line, and I'm going to click it onto this side line and this back line, and that'll sort of constrain the ends of the line. But you can see that the line itself is still this light blue color, which means I can move it. It's not constrained yet. It is attached to the side here with these constraints right here. These are coincident constraints, but we haven't given it any other constraints, not enough to turn the line black and lock it into place. So I'm going to do something to fix that. Let's see. We're going to use the dimension tool, that's D on the keyboard, and I'm going to select this point and this point, because I know that measurement from out on the box. And I'm going to drop this dimension and type in 11.5 inches. And if I commit that, now we know the distance of the end of the line to the front of the box. I'm going to do the same thing here for the backside, that point and that point. And I'm going to dimension that to 16.25 inches. And now you'll see that line is turned black because we are constrained. We're fully constrained. All right. So now we kind of have that corner properly cut. And we can go finish the sketch, and we see that that sketch line is there. To do something about it in the actual body here, we are going to edit our extrusion by clicking on that, and I'm going to click that corner to unhighlight it so it's not part of the extrusion anymore. And now you can see that corner is sheared off. And we'll click OK. And now we have our shelled out carcass with that corner cut off that looks like a chamfer. So it was hollow. This is going to be a wire pass through. And since I don't need to be perfectly accurate, all I'm going to do is take this face and I am going to extrude it. And I'm going to use the extent type to object. This means we're going to extrude this plane to another object. And I'm going to select the backside as the object. And then you're going to see that it automatically detects that we want to do a cut operation. So it's red to show that, and I'm going to click OK. And now we have a hole through there. So that pretty closely resembles the plywood box. And then you can go from here and continue adding features to this box, like the cable pass-through, maybe some of the holes that were up here to mount the inverter, and some of the cross members up here. The way that you do that in parametric design is you now sketch on these new planes. So I would choose this plane if I wanted to create the cable pass-through and create a new sketch. And then it's going to show you that in an orthographic view, and you could start sketching out where that cable pass-through is, constrain it, and then extrude it through to cut through the plywood. All right, that's enough for now. Let's look over at my box design. Quick break here to just say thanks for watching. This is a very different style video than I usually make, and that's because it looks like our members only videos. And I'm releasing this one to the public so you guys can see what it's like to be a member. If you're enjoying it, click the join button down below and you can become a member and get all the past and future members only videos. Today, I'm also announcing another little perk for our members, just a way to say thank you. Shar has been working on a map of some of our favorite places we experienced camping in Baja, the United States, and Canada. So you can check that map out when you become a member. We'll link to it in the post tab on YouTube or on the members only channels on Discord. I hope you enjoy it, and we'll probably add some more of our favorite places as time goes on. All right, back to Fusion 360. So here's my complete design. It has all the components that we need for the mobile smart home automation system that's going in this van. I'm using the component feature of Fusion 360 to keep each of these components separate. You can deal with each of them, and they each have their own timeline as they were constructed. This also allows you to move components around and keep them organized. Something we're doing for this build is using DIN rail to mount most of these components. So I wanted to simulate that in the model. And you can see here, I'm using sketches that resemble the dimensions of DIN rail to mount these components to. And I also wanted to make sure that we represent the little bit of depth that DIN rail takes when it's mounted on a surface. So if I change to an orthographic view here, and zoom in a little bit, you see that I've got these sketches offset from the side of the wall a couple of millimeters, just enough to represent that thickness of the DIN rail. So if we roll our timeline back to here, you'll see where we started sketching those DIN rails. And this is what a sketch looks like. I've built DIN rails just out of these rectangles with dots across to kind of give me multiple points where I can mount these components. I'm also sketching in the same sketch the cable chaseways where we're going to route all the cabling between each row of electronics. All right, so let's go through adding another component so you can get the basic idea. I'm going to fast forward all the way to the end here, and I'm going to add a new component. Let's say we want to add an access point. We'll just call it AP. Great, now we're inside this new component called AP, and we need to create the basic shape. So we're going to create a sketch, and I'm just going to do it on this plane here, and we'll place it later. So we'll use a rectangle, and let's say our access point is 4 by 4 inches. I'm going to select this and extrude it. Let's say it's 1.5 inches tall, or thick if you prefer, and I want to give it a label like the other one. So I'm going to now sketch on this face, and I'm going to create text. And I'm just going to call it AP. I'll center that text, and I'm going to make it 1/2 inch height. Okay. Now I can select Maybe. There we go. I can select the text, and I'm going to hit E for extrude. And I'm using another feature of Fusion called formulas. So in extrude distance, I have a formula already set for text relief at 0.01 inches. It's like a variable. So if you wanted to change something that is universal to a bunch of components in your design, you could change it in one place and it'll update everywhere. So if I want to change how far this text is extruded off the face of each of these, I only have to change one variable. But for now, it's 0.01 inches. And I'm going to create new bodies because I want to give a different texture to those. And I'll click OK. And now we have our access point with a little bit of geometry to show as a label. So to place this in our design, I'm using something called joints. And that allows you to take one component and mount it or join it to another component and place it in your design. And that's remembered in your timeline. It becomes a feature in the timeline that you can edit and change later. And this is going to allow us to move things around really easily. Okay, so now we need somewhere to mount this to. So let's create another piece of DIN rail up here on this wall. So I'm going to highlight this sketch, and you'll see that it shows me in the timeline which sketch that is. And then I'm going to double click that sketch so we can do a little bit more work in here. All right, I'm going to adjust that dimension tool there, and I'm going to create another piece of DIN rail using a rectangle. So I'm just going to draw this rectangle out, and I know it's 35 millimeters tall. And let's do another 9-inch piece of rail. And we'll kind of get that placed where we want it. Zoom in a little. There we go. Now I'm going to create a line, and I'm going to turn on construction line because this is just a reference. So I'm going to find the midpoint there. That's that little triangle. And I'm going to draw a midpoint line across. And you'll see it's a dotted line now because that's what construction lines look like. Then I'm going to create a point, and I'm going to find that center point here. There is the triangle. I'm going to highlight that point, cancel this tool. Now I'm going to select that point, and I'm going to pattern that point out using a rectangular pattern. That's going to allow me to replicate this really easily. In the distribution, I'm going to use spacing, and I want them every ½ inch. And I think I need something like 19 of these. And I also need the direction to be symmetric. Yeah, perfect. Now you can see that these are symmetrically distributed using spacing every ½ inch from the center in both directions. And I'll click OK. So now we have a little piece of DIN rail that we can move around. I can move it up and down. I can move it anywhere I want because I have not constrained these outer lines. They're still light blue. But in this case, I actually want that because I want to be able to move this around. So I'm going to click Finish Sketch. And now we have a place to attach our access point. So I'm going to use the Joint tool. Click Joint. I'm going to select the back of our access point. I want the middle of it. There we go. Ooh, cancel. That was bad. Okay. I goofed up there. Okay. Something went wrong. I think I had the sketch selected and I jointed the sketch to the geometry. I don't know, but I'm going to delete that feature. And that puts everything back. That's the beauty of parametric design. Just undo. Okay. So make sure we don't have anything selected. And let's try this again. Our joint tool's there. Now I'm going to pick a point on our DIN rail simulator here. And let's go right there. And you'll see that's going to snap up. Now our AP is 90 degrees off from what I want, so I can use this dial to turn this up. I'll just type 180, and I'm going to commit to that. Okay, great. So we have placed our access point now on a piece of DIN rail, and I can just grab this sketch now and move this DIN rail around, and anything attached to it is going to go with it. Now, one of the things I don't know if I mentioned earlier, if we look at this orthographic view, is that I'm actually sketching these DIN rails off of the back wall just a little bit. And that's because DIN rail has a depth to it. It's a few millimeters, I think almost 8 millimeters. So what I've done is I've sketched on something called a construction plane. So if we go find our left side rails, you'll see that I have a construction plane here. And this plane, if we find it in our timeline, where are you? It's way back here. This construction plane is 8 millimeters off of this back side of the wall. And I could adjust that, and everything would adjust down the line. Then our sketch that we drew the rails on here is attached to that construction plane. So we're actually sketching just a little bit off that back wall to help simulate the DIN rails. All right, so we can turn our construction plane off, and you can see we have a pretty complete box. If I wanted to move this access point somewhere else entirely, I could simply edit this joint and choose a new snap point here. And I could go over here, or I could snap it right here, and it's going to move that AP over there. I'm going to cancel that. Of course, I don't want that. Another nice feature of the joints, if you edit this, is you can make little micro adjustments inside this actual joint point if you want. If you didn't have quite enough dots or you have some other use case, you can modify that a little bit and it will be captured as part of this joint feature. I'm going to cancel that. There's also a whole world of things you can do with joints to animate them and constrain them to allow you to simulate motion around pivot points and all kinds of crazy stuff. For now, I'm just rigidly mounting these objects so that I can design this space. So I'm just using basic cubes for most things. I rounded the corners of this one a little bit, but then you can see I've got something much more detailed up here. And that's because I was able to import the geometry for these exact modules that I bought. These are Phoenix contact distribution blocks that are going to snap onto DIN rail. And you can actually see, if I turn our box off here, you can actually see exactly how those are mounting onto our DIN rail there. Our simulated DIN rail. They snap right on. So there's a lot of components that you can actually find and download and bring into your model. These have a lot more geometry to them, but it's kind of nice to see the actual design. You can often find the step files for components that you're using and integrate them into your design. Companies like Victron provide really detailed step files for everything they sell, which is super cool. So you could import that and lay out your entire Victron electrical system using the exact shapes and sizes. What I'm doing is just looking up the data sheets for any of the modules that I'm using and looking at their dimensions and sketching them out just so I have a basic shape. Quick interruption here to say, if you're wondering what all these components actually are, what I'm using, and how I'm going to integrate it into Home Assistant, don't worry, I'm going to get to that. But for now, I'm just trying to get the layout done right so that I can start installing these modules in the box so I don't hold up the actual build process. All right, let's get back to Fusion 360. The next thing that I looked at was wire runs. All these black boxes here are our wire chases. And I'm just executing these in our sketches for the DIN rails. So if we go back to this sketch, you can see I've also just drawn out these wire chases. I'm using 2" by 2" wire chases. So again, we just do basic rectangles, and then we use extrude commands to pull those out another 2 inches. And I've just got those hooked together here so that they make a basic wire chase shape. One of the other features I really like to use while I'm designing, especially inside a small space like this, is the section analysis tool. I've already got a couple set up here, so I'm going to turn that on, and you can see we can look at a cross section of the right side only in this case, or I can look at the back only, and we're just basically chewing away the geometry from those other parts of the box, so it's a little bit easier to get in here and look at what you're doing. And I have a left only as well, and you can modify this by double-clicking it and dragging this cross section. It's a pretty cool way to look at what you've got going inside something, especially if you're designing an enclosure or something like that. You might want to see the cross section. So with a pretty small amount of effort, this tool is really allowing me to sit and consider where I can place each device. In this case, I'm thinking about things like, where does our router go? We've got 7 antenna wires that need to come down from the roof, and they're going to come right down the back D column of the van, come through here, and I want them to be as close to the router as possible because they're only 15 feet long and they have to come all the way from the roof. And then I'm thinking about how Starlink is connected here, and our networking distribution, this is our PoE switch, is close to a lot of the network intensive things. So we kind of have our networking side, we have our IO and control on the back, and our DC distribution is on this side, as well as some of our switching distribution. Another nice thing you can do when you're in a situation like this is just use some really basic shapes to figure out if you're going to have any obstructions. For instance, this is the garage drawer just sort of mocked up. The team here told me it was going to be about 5 inches tall, so I modeled that up really quickly so I can just see what it will be like to look at this box when there's a drawer in front of it. So as you can see, I'm sort of avoiding putting too much stuff down in here. Even though we can reach down in it, it's nice to think ahead about what's going to be happening in the real world. And if you're looking at this going, wow, there's a lot of wasted space in here, I say don't worry. There's a front panel up here that's going to have AC distribution, which is going to occupy some of this space in the back here with wiring, but it is going to be removable, so we can pull it off the front and get to all of this stuff behind. We also want decent airflow. So air is going to flow from that other cabinet through here, and we're going to have vent fans here pulling that air up and out. And so you'll see that there'll also be airflow from this back corner as well. Another thing you can see is this hole that I've got in the bottom. This is a pass through to the underside of the van. So I wanted to make sure to know where that was going to land so that the wiring coming up from there can enter our distribution channels and find their way to the correct connection point. All right, we'll turn off our front panel and our garage drawer. The last step for me was just to add some color coding just for quick visual reference, but there's also a feature of Fusion I like that if you hit Shift-N, this is going to assign components random colors, and it just kind of helps visualize this really nicely if you haven't applied materials already to any of your components. But if we turn that off, we'll go back to our assigned materials where I've put a little wood texture here and a couple colors. All right, so now is the fun part. We get to export this in a format that's going to let us look at it as a 3D model and interact with it, as well as use it in augmented reality. In Fusion 360, this is super easy. We go to File, Export, and we choose the USD file format. It's a USDZ file extension. Choose where you want to save it, and we'll export it. And I'm going to overwrite the one that I've done earlier. And then if we switch over here, you can see this file right here. And right in Mac OS, we can quick view this, and we can see our geometry here. Now, because I built this from the center of the origin point, it's rotating around that corner. But that's actually going to come in useful when we're doing augmented reality, and we want to anchor this box to that corner of the actual box and in the physical space. So I don't mind that. But you might want to work from the center of the origin so that your model lives right in the center of this 3D preview. This is built right into the OS, and it's also built into the iOS and iPad OSs so that you can just open that file instantly and start scrolling around. And if you have cameras and LiDAR sensors, you can also use the AR or augmented reality feature. And because I saved this file directly to Dropbox, I can open it on any of my devices by just opening the Dropbox app and tapping on the file. All right, let's take a look at how this works then in the real world. So now we just open this file on the iPad, and it's going to snap to this surface. I'm going to set it up in the middle here, and we could look around what we've built. Then we can really think about how this is going to work. Now this comes in as 100% size, 100% scale, but you can scale it down if you need to. And you can see that the AR software is finding the surface of this desk. It's so cool. Now you can imagine how powerful this would be if you're standing inside your van. So let's go take a look at that. Okay, we're here at Sarah's van, and you can see a lot of the wiring has been roughed in and run to this back corner where our electrics box is going to be. So I'm going to jump inside and take a look at our layout inside the actual space. And now we can see how this actually works. You can see where our cables are going to come in here, and you can see how our hole lines up. And I think things are looking pretty good. But can you imagine if you just did a basic layout for your entire build, loaded it into AR, and then walk through your space to see how you like it? Or if you don't have your vehicle yet, you could just do it out in an open piece of floor. It's a really powerful tool, and it doesn't really take that much effort to put together. It really helps me plan, and I hope this will help you plan as well. So that's how I'm using 3D software and AR to plan and design the smartest van ever. Let me know in the comments if you've ever used a piece of software like this. Which 3D software platform do you like? And if you haven't, let me know if you plan on trying it. Also, let me know if you try out AR. It's a pretty cool way to take a look at your work in the real world or collaborate with others to make sure you're on the same page. Thanks to all Smarty Van members for supporting the channel. It really means a lot. And if you're not a member and you liked today's content, click the join button down below to become a member. You'll get access to all the past and future members-only videos, as well as some other fun perks. Also, don't forget about the Discord server. We're 700 strong, nerding out about mobile and non-mobile smart home technology. All right, I gotta get back to work testing cameras, dashboard, tablets, and all kinds of good stuff, and I gotta make the next video. Until then, how about this one?